In this video, we're going to continue examining how to graph square root functions by identifying the a, h, and k value of the transformations and plotting on the graph, and from there, state the domain and range. So here we have y equals the negative square root of x plus 5 minus 6. And so the first thing I do to assist me with graphing is I'm going to identify what my a value is, what my h value, and my k value. That'll allow me to see if there's a reflection, if it's going to increase faster or slower, if there's a horizontal shift, and if there's a vertical shift. Well, here A is -1. H is the opposite of what we see, so it's -5. And K is -6. Do remember that you have y equals A times the square root of x minus h plus k for your transformation setup. And so what does this tell me? Well, this tells me right off the bat that my starting point of my graph is the HK coordinate. So my starting point is going to be -5, -6. I cannot go beyond -5 to the left. So I'm going to plot that point. I'm going to plot right away -5, -6, because that's the starting point of my graph. So -5, down to -6, and here is my starting point. And from there, what we can do is we can state our domain and state our range. Remember, your domain represents the relationship of the x values. And so if I want to state my domain, I cannot go beyond -5 to the left. This is the starting point, so my x values have to be greater than or equal to -5. My range is based off of my y values, which is represented by my k. However, also for your range, you have to keep in mind your a value, because when a is positive, the graph is opening up. When a is negative, that means it's opening down, which affects the inequality for the y. If it's opening down, then y has to be less than or equal to -6. And so now that we have the domain, the range, we have our starting point, we know our a, h, and k values, what we're going to do is we are going to use our calculator and the table from that to assist us with graphing. So let's get out our graphing calculator. We're going to input in our y equals our square root function. So -2 x squared for square root, and I do x plus 5. Again, if you have the old operating system, you're going to have to close the parentheses around the square root. With the new operating system, what you're going to have to do is hit the right arrow and then put -6. So I can take a look at the graph if I want to see what my graph should look like. And so I see it does look like our -5, -6, our starting point, and the graph is opening downwards. So my domain and range do match the graph. So now let's do our table of values. And so our starting point is -5 for the x. And so I'm going to scroll up until I get to -5 for the x. And remember, the general rule I have for using your calculator to get the table values is to at least write down your own table from the calculator and include 3 nice points, 3 points that are integers. So the starting point we can use right away, -5, -6. It looks like we're at -4, -7, and then -1, -8 is the next one. So all I need are 3 nice coordinates from the table, and you write them down, and then we just plot them. So at -4, I'm at -7. At -1, I'm at -8. And remember, this represents your starting point. You can't go beyond it. And so you start here and you draw your curve for the square root function. And there's our graph. So the values of a, h, and k assist us with our domain, our range, our starting point, which allows us to know where to put our table of values in our calculator and then to graph from there. So let's look at another example. we have y equals 3 times the square root of x minus 2 minus 3. Again, your first step should be to identify your a, your h, and your k values. So a is 3. H here is positive 2. And k is negative 3. And right away, that tells me I know my starting point, hk. My graph is going to start at the coordinate 2, negative 3. And so I can plot that right away. I know 2, negative 3, my square root graph is going to start right here. And then we can figure out what our domain and our range is from those h and k values. So, domain is the relationship of the x values. And so we take a look. It describes how our graph on the x-axis looks. And so our starting point is 2 for our x. And so x is greater than or equal to 2. Our range describes our y values. And that's based off of negative 3. And we have to keep in mind your range is based off the k values. However, our a value also affects it based off of if a is positive or negative. If a is positive, the graph opens up. If a is negative, the graph opens down. And so this one is going to be pointing up, which means y is greater than or equal to negative 3. And so that represents our domain and range. We have our starting point. We have our a, our h, our k values. And so what we're going to do is, again, go to our calculator. So I still have my graph from my old one, so I'm going to go to y equals, clear out my original equation, and type in 3 square root x minus 2. Old operating system, close the parentheses. New operating system, hit the right arrow, and then minus 3. And I can look at graph to see 2, negative 3 is my starting point, and it is going up. I can go second graph for my table of values. Look at this, error, 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 error. Now, why is our table saying error? And the reason why is, what is our starting point? It's 2. And our x values are negative 5, negative 4, negative 3. So we are at all the points here that do not exist, because if I were to plug these numbers in for x, I'm going to get an imaginary number, which we can't graph on the real coordinate plane. So you do have to have some common sense with using your calculator that this starting point tells you where to start your table of values. And so I want to start my table of values at 2. And you notice when I start at 2, right away that error disappeared and I have my value of negative 3. And so I grab my table of values. And as I said, you want to write down 3 integers in your table. Just copy them from the calculator. So my x column, my y column. You have 2, negative 3. You have 3, 0. And you have 6, 3. And then plot them. At 3, you're at 0. At 6, you are at 3. And you have to start at the starting point and go up with the curve through these points. And you notice this curve is stretched vertically. And the reason why is because the size of A is larger for it. And so I hope this assists you with actually, from a blank slate, finding the AHK values, graphing with the domain and range. So now let's look at a standardized test example of identifying the domain and range of a square root function. And so we have y equals the negative square root of x plus 1 minus 4. What we're going to do is identify our a, h, and k values from this. A is negative 1, h is negative 1, and k is negative 4. By identifying a, h, and k, they assist me with my domain and range. Let's do the domain first. The domain relates to the h value, which is negative 1. So x has to be greater than or equal to negative 1. If I look at my domain choices, I see that B and D say x is greater than or equal to positive 1, which is false. It has to be greater than or equal to negative 1. So B and D are not my choices. I then go to my range. Your range relates to your k value of negative 4. However, the sign of A tells us if the graph opens up or down. And so since A is -1, the graph is going to open down, which means Y has to be less than or equal to -4. And so that means C is not my choice, but A is my choice. And so this was an example of no looking at a graph, just identify A, H, and K, and you can actually describe the domain and range of a square-root function graph to me for it. And so I hope you found this helpful with your transformations with A, H, and K and stating your domain and range.